Hello Funny fanatics, this is Electronics with Funny. In this video I will show you how to correctly use your multimeter. This is a must-have tool in any electronics or electricity workshop. With it we can measure voltage, current, resistance, temperature and frequency. There are analog and digital multimeters. Both can give you precise measurements if we choose the correct range, but we'll talk about that later. This is an analog multimeter. They are not used a lot these days because digital multimeters are more precise, especially in the finer ranges. Their advantage is their low price. Setting the range is done as with other meters in the market. Turn the knob to set the quantity to measure and its range. It has a screw for zero setting. This has to be done without performing a measure. The working principle is the use of a micrometer that moves on a scale, but in this video we will talk about digital meters. Digital multimeters have a numeric display to read the measured values. Here are some of the meters that are common in electronics and electricity work. This is the most used type of multimeter in electronics and electricity. There are low-priced ones with only basic functions, or more complete units with auto-scale and other features. Let's do some measurements with our digital meter. The first thing to do is to connect the test leads to the meter. You have to set your meter in the parameter that you will read, such as voltage, current or resistance. For any measurement, the black lead is always connected in the COM jack. If you want to measure voltage, resistance or frequency, the red lead goes in this jack. But if you want to measure large currents, the red lead will go in this jack. Most meters can read up to 10 amps. If you measure a larger current, the internal fuse will blow and you will have to put a new one of the same kind. For currents of less than 1 amp, the red lead will go in this jack. Now that we know how to put the test leads, let's see how to set the rotary switch. Next to the rotary switch, we can see the different parameters that we can measure. In this case, we will read voltage. Therefore, I will move the switch to the V position. Keep in mind that some multimeters, especially the expensive ones, automatically select the measurement range. Therefore, you do not need to do it manually. Depending on the type of current, you need to put the switch on AC or DC. With this type of meter, if you see a 1 in the display, that means you need to go to a higher range. Let's do our first measurement. Let's measure voltage. In the case of DC, we put the red lead in the positive terminal of the voltage source and the black lead in the negative terminal. If you see a negative sign, that means the polarity is reversed. Swap the position of the leads and now you have a correct reading. After measuring voltage, I will now show you how to measure resistance. In order to measure resistance, set the switch in the ohms position, the omega symbol, and put the test leads in the resistor to be measured. If your meter is not auto-scale, select the range that gives the most precise reading. In this case, there is no polarity, therefore you can put the test leads in any position and the reading is not affected. You can also use the continuity test function with sound to see if a circuit is open or closed. This is useful to check for blown fuses. Remember that in the case of semiconductor continuity, such as in diodes, polarity is important. Now let's measure electric current. In order to measure current, we set our meter in the amps position. We need to know if the current to be measured is AC or DC. Remember that there is polarity if you are measuring DC current. Current in a circuit is always measured in series with a resistor and the power supply, closing the circuit with the meter. Never measure current directly from the power supply, because in absence of a resistance, the current will be very high and the fuse will blow. Another way to measure current is with a clamp meter such as this one. The advantage of this type of meter is that we don't have to open the circuit. You only have to open the clamp and put one wire inside of it. This meter works by electromagnetic induction generated by a current-carrying conductor. This way of measuring current is very convenient, but it has its limits, because we can only use it for AC currents. However, we can measure very high currents without worrying about damaging the meter. In medium to high-end multimeters, we can also measure temperature. With a probe like this, we can take precise measurements of temperature. Usually, the temperature probe is connected in the cohm and milliamp jacks of the multimeter. Move the switch to the degrees position and you can read the temperature in the display. This type of sensors are made with a thermistor, either NTC or PTC. The internal resistance varies as function of temperature, and those variations are interpreted in the meter. Many multimeters have a hold function, which allows to maintain the last measure in the display for as long as you want. Now let's see how to measure frequencies. In order to read frequencies, connect the test leads in the cohm and hertz jacks, which is the same as for voltage and resistance. This measure do not have polarity. You can put the leads in any position. Let's take a measure. With the oscilloscope, I will generate a frequency of 1 kHz and then measure it with our meter to see how it works. As you can see, the reading is the same as the frequency generated by the scope. In our next electronics tutorial, we'll talk about regulated power supplies, a very important device that must be present in any electronics workshop. Okay, funny fanatics, that's all for today. If you liked the video, click like, leave your comment, share with your friends and in your social networks, and subscribe if you haven't done already. See you later. Kisses.
Si usamos una medición que supere ese valor, se nos fundirá el fusible interno. ¿Qué dije? Hay algunos con una sonda como esta que podemos tomar la temperatura. Este es un multímetro analógico. Este es un... estos medidores para comprobar si un